Hello, Guitar Joseph. Thank you for following and thank you for joining the stream. Thank you for the support. Thank you for the support. We've got 2 viewers. We're going to wait for the others. We'll give them around like 10 minutes. So we will start officially at 2040 hours EAT, East African time. Yeah, thank you, the 2 viewers, for being punctual though. So the question is, how did you get over the barrier of creating basic ML and DL models to quality competition winning ones? I'm really stuck here. So to be honest, I feel like it's experience. The more you participate in more competition, the better you become. Since after each competition ends, like some winners are very generous in sharing their solutions. So what I did when I was starting, I was going to read the winner's solution and even trying to reverse engineer them after the competition ends, and then trying to understand what they did differently from me. But yeah, it's a matter honestly, it's a matter of experience. The more you compete, the better you become. Also, given how we started the landslide challenge, we started with a pretty low score. Then we iteratively improved by doing what other people do to win. Like, for example, changing the models, training on 5 folds instead of a single fold. So these are things you learn after the competition ends and after reading the winner's solution. So my advice to you is participate in as many competitions as you can, and even after the competition ends, when the winners post their solutions on GitHub, for example, just go and try to reverse engineer or see what they did differently. Yeah, that's my advice. I hope that helps. Oh, and I saw you got into Google. So congratulations, man! Congratulations, man! Yeah. Yeah. So my database is my GitHub. So if you go to my GitHub, all my winning solutions, all the winning solutions I've done, I've won, are in my GitHub repo. So if you go, so for example, the most recent one is a mini. I mean, Ikoko, this was third. In Vendata, we were second. Spatial temporal, yeah, we were first. I was first. This I participated solo. So like, for example, when this competition ended and I like posted my solution, my repository on GitHub, you just come and try to like go through these notebooks and see what I did. And then if you did something differently, try to like even copy what I did and see if it's could or it will improve your workflow. Yeah, so that's my process, honestly. That's my process. Yeah. So for example, like I'll give an example. In this competition, which has ended like some few hours ago, this the ARC challenge. I never like actively participated. You see, I only submitted one sub, and it was like the help. It was because of like this discussion. I never competed actively. So, for example, in this competition, I'll wait for maybe the top three guys to share their solutions, and then I go read what they did, and then I try to like work on that myself. Yeah. Oh, nice. You are position 12. Yeah. Position 12 is actually great. I would love to hear what you tried. Honestly, for me, I never tried anything. Like, yeah, I never actively participated in this competition. But I will be eager to learn from what you guys did. Yeah. But this discussion, I read this discussion. Uh, this, thank you, ML Wizard, and it was a very nice discussion. He even provided a notebook. Yeah. So you can go. Honestly, I'm waiting for the winners to post their solution for me to read about them, especially these. Hey, this is impressive. 92% accuracy. That's impressive, man. That's very, very impressive. I hope they share the solutions. Yeah, I really wanted to participate in this competition. I actually wanted to like open it as a knowledge competition because it was interesting. Since all companies now are chasing AGI, yeah, I wanted to be part of that. I wanted to be part of that, but I like the time limit, plus I'm in other competitions which are taking most of my time, plus work. Yeah, so if the time limit was like 2 months, maybe I would not maybe I would have participated in it, but yeah. I really hope they open it up as like a knowledge competition so that we can practice our AGI skills. Yeah. Okay, it's already 2040 hours. So I think we can start. So a quick recap of what we did yesterday. Yesterday was basically building our first baselines for us to like try to beat them in our other future experiments. So we tested a lot of like web to vec baselines, and the best based on the stream was like this fine-tuned model from Alam Shah. So and we saw there are many web to vec models. Yeah, so you can try all these. Yeah, you can try all this. We tried some on the stream, and the best we could get was like 0. Yeah, the best we could get was like 0.5587, which at that time it had placed us on top 5. But then I continued hunting after the after the stream ended, and then I got this model, which scored 0.466 with no fine tuning at all. Like I just went and looked for a fine tuned model already on Hugging Face, and then I performed inference with it. I'm not going to share which model I used, because I want you to like test all of this. The competition is like very, like, the time remaining is very long, so you have a lot of time to experiment. You can even take like one whole week of like experimenting all baselines on Hugging Face before starting the whole training process. Yeah, so the best we got is 0.466, and today we are going to do not web to vec anymore. Yeah, because the repo I shared yesterday, we saw there were two approaches that I did. I trained a web to vec. And a Conformer CTC model. Yeah, so today we are going to focus on Conformer CTC models. We are going to try to find baselines trained using Conformer CTC. Yeah, we are going to find baseline trained using this approach. But before that, yeah, what is Conformer CTC? Yeah. So Conformer CTC is a model by NVIDIA. Yeah. I hope you can see. Yes, so Conformer CTC model is a non-autoregressive variant of Conformer model for automatic speech recognition, which uses CTC loss decoding instead of transducer. For more information, refer to the Conformer CTC model documentation. Yeah, nice. Yeah, so has a similar encoder as the original Conformer, but uses CTC loss and decoding instead of like RNN or transducer loss, which makes it a non-autoregressive model. They also dropped the LSTM decoder and instead use a linear decoder on the top of the encoder. This model uses a combination of self-attention and convolution modules to achieve the best of the two approaches. The self-attention layers can learn the global interaction, while the convolutions efficiently capture the local correlations. The self-attention model support both regular self-attention with absolute position. Okay, you can go read this. I'm not going to read it on stream. Yeah, for the people who love researching, you can go read this. Yeah, and now we go to the training, to the inference part, where we hunt for like baseline models trained using this approach. But so remember, yesterday we have to work, we ran them using Hugging Face. We tried pipeline. Also in this stream, we are going to fix the pipeline issue, hopefully. And today we are not using AI to code because like yesterday we used AI and we were unable to solve the issue. So like today I'll code them myself. Yeah, so for conformer models, you have to use an NVIDIA toolkit called NVIDIA Nemo. Yeah, NVIDIA Nemo. So yeah, so we use this toolkit from NVIDIA to run the fine-tuned models and even the base models. Yes, 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 yes. Uh, you can go. Oh, I need to link this on the chat. And yeah, even these. Cool. With that out of the way, we go to coding. We go to coding now. We create a new notebook. Josh the dev. Thank you for following. Thank you for following me, man. Thank you for following. Bro, we are at 17 followers. This is a massive, massive win. Massive, massive win. So yeah, thank you for following. The goal was 25 followers by the end of the month. By the end of the month, man. By the end of the month, I feel like okay, today's the last day of the month, but no, that like a month after we started. We started like 1 week ago. This is the second week, so we still have 2 weeks to reach our 25 milestone. So please, if you're watching this on YouTube and you have not followed me on Twitch, make sure you come here and follow me on Twitch. Yeah, and also if you have not subscribed to my YouTube channel, please do, please do, please do, please do, please do. Cool. So today we are going to do to run Nemo baselines. So Nemo ASR inference only. Yeah. So we install the toolkit. The installation takes. We also change the runtime. Today we are going to use RT4 GPU, since that's the requirement in the resource. I mean the compute requirement that we are supposed to adhere to. So yeah. So we install the Nemo toolkit. Yes, and if you never watched yesterday's stream video, please go watch it. We focused on more on Web2Vec. Yeah, today we're focusing more on Nemo. So if you want more Web2Vec approaches, I mean inference only approaches, you can check the last stream. And yeah. Yeah, the installation takes a little bit of time. Yeah, we are just waiting for it. As we wait, let's continue the other steps. So what dependencies do we need to import? We need pandas, obviously. We need pandas. We need datasets. To help us load the HF datasets. Yeah, and also audio. We need a TQDM for progress bars. We don't need that. We need IO for playing the audio. Yesterday we never got to play the audio, yeah, because of an error, which I think I know the solution to it now. We import sound file. This will help us convert the bytes audio stored in the HF dataset into arrays, NumPy arrays. We need what else? Oh, we need the Nemo. We need Nemo from Nemo.collections .asr import Nemo ASR. Hello, my four viewers. Thank you for following. Thank you for joining the stream. Thank you for joining the stream. Today we are focusing more on Conformer CTC baselines, inference only approaches. Yeah. And I've shared links to the, what's Conformer, and how to run Conformer models. Wayne, how are you, man? Thank you for joining the stream. Yeah. So today we are focusing on Conformer models. And to run Conformer models, you don't use Hugging Face. You use Nemo toolkits from NVIDIA. Yeah. So this toolkit right here. So this is what you are going to use. The links are on the on the charts. Yeah. So we install the toolkits, and then we import the inference method you're going to use, Nemo ASR. This is for converting the bytes audio into a suitable format for inference and loading. OS, progress bar, load the dataset. Pandas does not need any introduction. Yeah. As it's still installing, it takes a while. We go back to a Hugging Face. So I know Nemo is not many people know Nemo. Conformer CTC models. Yeah, so this I tried it in a previous hackathon, and it was performing pretty well. So I think the saved fine-tuned models are very few. They're very few, and most of them are from me. And actually, they were private. So I'll just set them to public right now. Yeah, I'll set them to. They're actually public. All of them are actually public. Yeah, so you can go check them on my Hugging Face. My Hugging Face is Collectionist, same as my competition username. Yeah. So we are going to try all of these today, because I don't think there are many there are many Conformer Swahili models. Yeah. I don't think there are many. Let's see. Let's see. Let's see. Honestly, I can't see any Conformer trained or Conformer fine-tuned models for Swahili. They're not like many as Web2Vec. Yeah. So you're only going to use mine. Yeah, I've set them all public. You can go try them. We are going to try all of them on stream though. Yes. So we have to restart the session. Otherwise, you'll get errors while loading pandas. Invalid syntax. Yeah. From. And then we create our config. By now you already know I love to use this to like store my like the configurations that like it's where you can easily change your configurations. You don't have to like go to the code and then find what configuration you use. You can just set them here and then use this config. Well, use this config. Cannot import Nemo ASR from nemo.collections.asr. Okay. Oh yeah. Sorry. You just need to import this and yeah. Cool. And then we set our config. The first thing, our dataset path. If by now you don't know which data we are using for inference, please watch yesterday's stream, bro. Please watch yesterday's stream. Yeah. We're going to set the dataset path, the model name we are going to use, device, CUDA, if touch.cuda is available, else CPU. So you need to also import touch. The model name, we're going to choose one from my Hugging Face. So we go back. Yeah, we're going to choose either of these. We're going to choose either of these. There are actually many. Yeah, there are actually many. Yeah. As you can see, most of them are private, so I'll just set them to public. Bro, let's help the community, man. We'll still win. No selfishness. We'll still win. So you can just go crazy. I've given you permission to use them. Yeah, I'll set them all to public. The Nemo models were actually so good that we actually made an app using the Nemo models. So like these are actually good. I hope it translates to the leaderboard though. We really can't say for sure until we submit on the leaderboard. Yeah. I'll just set them all. Yeah. I'll set them all to public, man. Nice. So all of them are now public. Let's try to search other STT models. That's Swahili based. Swedish. Wait, is this a Swahili model? Because I can see like the Swahili abbreviation, SWA. Yeah, so you can try these ones. But I'm not sure if they are Swahili models. They have not said it on the model card. Yeah. You can try. I know this is a Swahili one. Badili is like a Swahili one. Yeah, you can see. Oh yeah, here is a Swahili one. Yeah, so we have options. Yeah, this is also a Swahili one. Kinyarwanda, Swahili, and Ganda. Nice. Kinyarwanda. This is Kinyarwanda. Yeah, so we have options. But you're going to start with one of mine. Yeah, we're going to start with one mine. So I'm going to start with I'm going to start with this, the last one I trained. Yeah, I'm going to start with this. Hopefully it works. I don't remember. Okay, yeah, hopefully it works. Yes, and then for the data, here is where you get the data, your test data. So this is you come copy this link, and then we are going to use it. Yeah, now everything is set. Now we load the data sets. Just the dev. Congratulations on your first time chat on the stream, man. Thanks for the support. Yeah. You guys are still very early. We are still exploring baselines. We haven't even started like training the models. Yeah. We are only doing inference only baselines. Yeah. So load the data sets. The S or test data is equal to data set, load data sets. Yeah. Split test. Yeah. DS. Test. We have to cast the So this audio method is you can go to this course actually and learn about audio processing. Learn about the sampling rates. What is the sampling rate I've been talking about? So I'll link also this resource on the chat. You can go check it out. So we load our data. It's going to and you have to provide access, by the way. So and I showed how to like add the secrets on yesterday's stream. And then we try to print, if it's successfully loaded, we try to print one audio. So you can see it's in bytes. Now, before even we continue, let's play this audio. Hopefully today it plays. Yesterday we encountered an error actually. So the reason was because two audios were conflicting. So import audio as HF audio to avoid conflicts with the one which is used to play the audio. So the other one is import audio, and then we fix this now. This now will use the HF audio. Yeah. HF audio is not. Nice. Yeah, and then we play the audio now. So like we get the audio bytes, which is test audio array. Instead of array, we have bytes. And then instead of this, we create an audio array using sound file. Sound file is this library we imported. Yeah. sf.read io.bytes. Yeah. And then we play the audio. So I'm going to, oh wait, we haven't imported IO. Import IO. And now we play it. I'm going to stop the Spotify music for a while. And let me on the chats if you let me know in the chats if you can hear this audio play. Especially my Swahili brothers, my Kenyan brothers. My Kenyan and Tanzania brothers. No, my East African brothers. Yeah, the countries which speak Swahili. So let me know if you can hear this audio.
Upana baina ya mita 64 na 75.
So let me know in the chats if you have heard that audio, my Kenyan brothers. Let me know if you have heard that. Let me know if you have heard that audio. I'll play it again.
Upana baina ya mita 64 na 75.
Yeah, let me know in the chat so that we can continue. We'll continue either way, but I just want. Great. Thanks, Gitao. Cool. So I'll play the Spotify music now. Nice. So the audio is playing. So everything is running as expected. Now. No. The other thing we want to check. Oh, wait. The sampling rate. Yesterday I just said 16,000. And you guys never knew where I got the 16,000. So like I think I've shared a link where it talks about what sampling rate is. I think the link will explain more why we use 16,000. So like even it's here. So the choice of sampling rate primarily determines the highest frequency that can be captured from the signal. This is also known as the Nyquist limit and is exactly half the sampling rate. Yeah, the audible frequencies in human speech are below 8, and therefore sampling speech at 16,000 hertz is sufficient. Yeah. So you can go, I've linked this on the chat, you can go read about it, like more on this article. Yeah, so we go back to our notebook. So what I want to do first, since everyone has people in the chats have heard this audio play, I want to like just use the model to try to perform inference on this audio, and we'll let the chat see the Kenyan, not the Kenyan. Why am I using Kenyan? Because I'm Kenyan. The East African brothers are on the stream to let me know if like that's the the actual sentence being said in this audio. Yeah, so we already have the audio array and the sampling rate. Now, the NEMO toolkit expects image parts of the audio, not the array, not the bytes. So you have to save this. We have to save this audio into like a .wav or .mp3 file, and then save it in the on the working directory, and then use the fine-tuned model to perform inference on this audio. Now the path, the image, like the audio, not the image path, but the audio path. Yeah, and just to save time, I will try to like. It doesn't take. I don't think it takes a lot of time to run. So I'll just create a temporary directory here that will save all the image, like all the audios, yeah, in my working directory. So we use a list, and then we look through our data sets in enumerate our test data sets. Or to visualize, you can also use the TQDM. This is just for progress bar utility to help visualize as the process. Yeah. Now we let the AI do its thing. Yeah. At least there's a human in the loop. It's not like yesterday we were just prompting the AI to write all the code. At least I'm guiding it. Yeah, I have to write a comment so for it to but all of them are 16,000. Yeah. So honestly, we don't need this step. Yeah, but you can. Okay, I'll add just a comment for you to go experiment with it. If the SR is not 16,000, resample it to 16,000. Yeah, but most of them are 16,000. I hope so. So yeah, that's a homework for you guys. Audio file, yeah. Then you use sound file to write the audio path and append it. Yep. So I think this is okay. And then when it ends, we can print one of them and see. Actually, yeah, we can print one of them. Yeah, so this is you see the TQDM we imported. This is its functionality, just to see the progress. If you never added this, you wouldn't know how many records have been processed. Yes. Whoa. I thought this is supposed to be printed. Yeah. So you can see they have been saved, and actually you can see them. You can see all the audio here. You can see all the audio here. All of them have been saved, and they have been saved using the indices. So remember, this audio, it was index 0, right? It's this now. So we're going to perform inference on this, and I'll play the audio again, so that you tell me if the model is performing well or not on the charts. Yeah, I'll play the audio again. So pay attention, my East African brothers. Yeah, pay attention.
Upana baina ya mita 64 na 75. Upana baina ya mita 64 na 75.
Yeah, so in essence, the wording is upana.
Upana baina ya mita 64 na 75.
Upana baina ya mita 70 na something, yeah.
Upana baina ya mita 64 na 75. Upana baina ya mita 64 na 75.
Yeah. So it's this audio that was playing. So we are going to perform inference now using the fine-tuned model. So let me. Yeah. So we specify our ASR model now is equals to NEMO ASR, the toolkit we imported above, dot models dot ASR model dot from pre-trained, and then we pass in the model name that is specified here. And all these models can be found in my Hugging Face. Yes, all these models can be found in my Hugging Face. So we can either choose either of these, honestly. I don't know why this is saved with a .nemo, but I can see it's the latest one. So I hope it works. I hope it works. Yeah, and it has all the necessary files. Yeah, this is the necessary file. It's like 487 MB. It's not even that large compared to our Web2Vec models, which we tested yesterday, which was like 1.23 GB. This is only 487 MB, and you'll see how well it performs. Like, I feel like this is the model I used to get to that place in the previous hackathon, the previous Mozilla hackathon. It's not even Web2Vec, but we'll see. We'll see if it performs well in this. In this. So yeah, this is the model we specified here. CFG is not defined. Oh yeah. So we have to specify CFG. No, like we can use the same way we use this. So we can use config, the class name. Hopefully it runs, man. Like it, yeah, it's okay. It's loading. It's loading. Nice. And it's very verbose. I don't know if there's a verbose flag. Is there a verbose flag? There's no verbose. Yeah, it's very verbose. Like it's really verbose. But yeah, no problem. So the goal is to transcribe the audio we have played, and I'll let the chats tell me if this model is actually doing a great job. If you had the audio, but yeah, I'm pretty sure you had the audio. So how to do it is you see this ASR like this you have initialized here is what you are going to use actually. Yeah, so ASR model dot transcribe, and remember it takes in a list of parts. It takes in a list of parts and returns the results. Yeah, so so these returns, okay. Let's just print it. It returns a list with only one audio, which is what we are interested in, the index 0, which we played. Remember, this is the one we played. You see this index right here? I feel like even this index should be instead of like, yeah, should be added in the configuration so that you can play with multiple of them. Yeah, and then you don't have to change anywhere else. So test index config dot test index, and here as well. Okay. Now to use now the config dot, you have to change this now. This assumes that the index you want to like process is at the beginning of the list. But if you want to check for the config dot test index you specified above, yeah, I have to run it like, yeah. Yeah. Nice. So if you change this to like 100, it will still work. Yeah, and it will return the 100 index. So that's how, like, so you see how it makes things easier. You just have to change. You just have to change here, and everything else you don't have to like touch your code anymore. Yeah. So this gets this gets deleted. Yeah, and we use this test audio. is equals to this, and then wait, let me see if it can process just a single, if it's not a list. Yeah, since it's only one, transcript. Nice. Great, it's working. It's working. It's working. It's working, man. So now, bro, I don't know what this guy is saying on the chat. I think it's spam. Anyways, now I want the chat to tell me. Now I want the chat to tell me if this is actually correct. Please let me know if this is actually correct. Yeah. Nice. So please let me know if this is actually correct. Let me know if the model is actually doing a great job. And I'll pause the music again, and I'll play the audio again. So pay attention.
Upana baina ya mita 64 na 75.
Yeah, so that was the audio, and this was the predicted transcription. So I'll let the chat tell me. I can see Jacqueline, I can see Gitau, Josh the dev. Yeah. Thank you, Gitau, for confirming. It's correct. It's actually correct 100%. 100%, yeah. Like the audio actually says this. Upana baina ya mita 64 na 75. And then we are going to try another one. Maybe this was a bit easy. So we are going to try another one. So we are going to change the test index and change it to like the 100 which we tried, yeah. And then yeah, we have to change this as well. Config dot test index, and rerun this again. Yeah, so let's hear this, and then we'll perform inference again. Yeah, so let's hear this.
Hadi mwishoni wa miaka 1800. Hadi mwishoni wa miaka 1800. Hadi mwishoni wa miaka 1800. Hadi mwishoni wa miaka 1800.
Okay, now so we have to run the inference step again. So this, you see the test audio has changed now to 100, and then we are going to run the inference again. Nice. And now, yeah, so let me know again on the chat if this is correct. I'm taking just a small. Yeah, I'm back. Can someone confirm it if this was correct? I'll play the audio again. I'll play the audio again.
Hadi mwishoni wa miaka 1800.
Again.
Hadi mwishoni wa miaka 1800.
Yeah, and now the predicted is hadi mwishoni mwa miaka 1800. Yeah, so I want the chat to let me know if it's actually correct. Thank you, Gitao. Thank you, Gitao. It's actually correct. It's actually correct. So you can see how these you can see how this model is very accurate. It's actually very, very accurate. Yeah. So, but we have only tested two. We have only tested two. So like now msema kweli ni when we submit on the leaderboard. So let's now do that. I'll return the music now. We're not playing any more audios. Thank you so much, Gitao and Jacqueline, for contributing to this stream. Thank you, man. Yeah, so right now we have to run it on, you see all these audio files, we have to run the inference on all of them. And the Nemo toolkit actually makes it very, very easy. It makes it very, very easy. All you need to like provide it is all of your parts. You see, we have like 4089 audio files, so parts. And if you compare it to the test.shape, yeah, you can see like the test set had 4089. So we have to perform inference on all of these. And what I'll show you how easy it is to run it using the Nemo toolkit. So we call the ASR model again, and then dot transcribe, and then we pass all these lists to it as an argument, and also we specify the batch size. So you can go crazy here, the batch size, but I want to start with 8. This also should be configurable in the config. So we set it here. Batch size is equals to like 8, and then config dot batch size. Yeah, and it's just like that, man. So nice. Now we have to wait for like 2 minutes for it to run. While it's running, let's prepare the submission. So how to prepare the submission is you create a list of dictionaries where you store you remember this, you remember all this. We have the audio, we have the file name and record ID, but the most important is file name, since this is the identifier which is used to in like evaluation, and now the predicted results. So we'll only store the file name, and remember they were saved using indices. So yeah, we still retain the original indices, and then our text. Let's see. The evaluation requires us to, yeah, so text. Text is now the transcription. Yeah. All transcripts.text for I in range length of the test set. Yeah, and then you store this in a data frame. So like sub is equals to bd dot data frame results, and then you visualize the first 5. Yeah. You can see how fast it is actually. It will take almost 2 minutes for 4000 audio files. I really hope it's like performs well on the leaderboard. It beats our Web2Vec baseline, which was around 0.56. Yeah, and our current best is 0.46, but that's not ours. Ours is like 0.5. Yeah, the one I trained in the previous hackathon, like around 0.56, 57. Yeah, so like now it has finished. Nice. And all of these look like perfect Swahili. So pana, baina, mwanadamu. Okay, I don't know this word. Mwanadamu vivulia. I've never had a vivulia in Swahili. But anyways, we speak bad Swahili. Maybe Tanzanians can help us. But yeah, Kenyan Swahili is actually bad. It's a mixture of English and Swahili. Yeah. But anyways, yeah, we submit now to the leaderboard and see how well the model performs. So we'll call it, for those guys who are in our previous stream, all our subs are saved using the model names. So config dot model name dot replace replace that with an underscore. Yeah, dot CSV. And then set index to false to avoid index errors. Yeah, and we submit. Let's see how it performs. Let's see how it performs. Let's see how it performs. Hopefully it performs well. Hopefully it performs better than this. Yeah. What? Oh, we faced this issue yesterday again. You see, we faced this issue yesterday. So the issue is, it's because like when the model fails to perform perform inference, it returns an empty string, and this strings needs we need to provide a value for them. Yeah, so we'll check this. Yeah. Sub file name is equals to this. You see, it's returning an empty string. So the simple fix we did yesterday was find every occurrence of these, so, and replace it with a space. Yeah, that was the fix we did yesterday, and we are going to repeat it here as well. np.where sub text is equals to an empty string, so replace it with a space, but for all the others, retain the predicted text. Wait, we had not imported an numpy. Yeah. So actually, when you try to print this, we can try to print it. So we can try to print. it. Text 0, so that you can compare the index, the correct index. Yeah, you can see it's an empty string. Yeah, but then when you do this, when you make this change right here, you'll realize it has turned into a space. So yeah. So when you try to print it again, yeah, you can see like now it's a space. It's now a space. So this will work now. Yeah, this will work. Wait. Yeah, it will work. Let's see if the others are still the correct ones. Yeah. Yeah, we refresh these parts, and then we download it, and then we submit it again. Yeah, hopefully it performs well. But we still have other models to try. So you have like a list of models to try. Bro! Bro. Guys, man. Guys, it actually performs better than this I hunted, man. And this, actually, this I'm so proud of it because it's mine. It's my model. It's my model we are using. So damn. I told you, bro, this model is crazy. We built an app using this model. But I'm not sure which one exactly. But at least this one performs better. This performs better. 0.44, man. Ah, man. I'm so proud of this submission. Now everyone on the stream will get 0.44. See, never miss a stream. Man. Never miss a stream. Don't you love that? Guys? Yeah, so we will save. I showed you guys how to save and pin submission. Yes, Jacqueline, be impressed. Thank you, Guitar and Jacqueline. Yeah, and actually, bro, maybe I don't get keep things, bro. The training code is on GitHub. It's open. Like this is the code I used to train these models. It's here. You can see NVIDIA Nemo. So you can go check the code. Yeah, but first try all my models on my Hugging Face and find the baseline to use for further fine tuning. Yeah. So we have to save this. So we save and pin revision, and then so this is how like I track the progress, like the version history. Yeah. So 0.44. So when you get another better than this, you do the same steps. So you come here, save and pin revision. When you save and pin revision, it will save. Then come here to revision history and rename the pin revision to like maybe a score or the model you use. Yeah, but since this you're only using, hey, you can even like name it the model you're using. Great guys. So we go hunt another model on my Hugging Face. Yeah, so this was the yeah, we'll try this next one now. And then repeat the whole process again. We restart session. We don't want to reinstall this because yeah, we don't want to reinstall this. So I'll just restart session and then run everything from here. Run cell and below. Oh, okay, Jacqueline. So we are trying to create baselines based on previously fine-tuned models. So yesterday we only tested web-to-vec models. Today we are testing Nemo models. But when we went to like Hugging Face to search for Conformer CTC models which are fine-tuned in Swahili, they were limited. But most of them are coming from me. So if you go to my Hugging Face, I'll link it here on the chat. Search for like STT models. Search just STT models, and you'll see a list of them. All of these are fine-tuned on Swahili. All of these. So you can go test each one of them to create a strong baseline, and then this baseline is what you'll like try to beat when you try. Since we are not doing we have not done any training at all using for this competition. We're just using like already fine-tuned models. Yeah. So we create a strong baseline. We try to beat it when we fine-tune the models ourselves. Yeah. So go to my Hugging Face. Search for all STT models. Go try all of them. Oh, and also follow me on Hugging Face. I have 4 followers. Oh, just a guitar already follows me, man. Daniel Toby, my brother. Yeah. Cool. I bet it's already fine tuning, yeah? Yeah. And also, if you never watched the video yesterday, I shared how I handle new projects. For example, if people like, I'm pretty sure beginners, when they come to like this competition, all they want to do is first start training, but they don't realize there are better ways to find, I mean, to achieve a better score, like a good score. You can achieve a good score without training. You just like need to do research. Yeah. So what I do is like go to past competitions, see what other people did. If they have open source their solution, go play with it. Yeah, 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 yeah. And tell your friends to join the stream, man. You can see the good things you are doing on stream for free, man. For free. For free. I hope. Okay. I don't know if it will perform better because I feel like this it performs the best since I trained it. You can see this was November 15th, 2023, but all others were like the previous month, meaning this was an improvement to all of these. But we never know. We never know. We never know. We never know. Nice. The other one has finished. So it's these, I bet. Yeah, 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 yeah. Yeah, 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 yeah. I can see like you can see like this performs better because it was like fine tuned later. But we can honestly still have time. We still have like 18 minutes, so we will test another one until the time ends. Until our time ends. So yeah, we will try until the time ends. So which one should we try again? Let's try this one. Let's try this one. Yeah, yeah. Let's try this one. Yeah, let's try that one. Restart session. Run column below. Okay, if this doesn't improve, I'll leave the rest to you guys. I hope the stream was interesting, man. Thank you for always showing up. Tell your friends to join. We are doing great things on stream. Yeah, yeah, yeah. Honestly, we don't need to like redo. We don't need to redo this every time. Bana, we don't need to redo this every time. So yeah, we don't need to redo all this. I mean, this every time. If it doesn't exist, that's you got a better score. Nice, 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 nice. Bro, guitar got a better score. Guitar got a better score. Yeah, so go crazy. Go test all the models on my Hugging Face. Yeah, go. And on stream, actually. On stream. Like, guitar got a better score on stream. So go crazy. Go test it. Go test it. Go test it, everyone. Go test it, everyone. Go crazy. Go test all my models, man. You never know which one will get will give you a better score. Yeah. And there are like there are many. Like there are very many. Oh, guitar used to this one right here. Yeah, so go crazy. Especially go in order because obviously the order matters. The reason why I fine tuned more is because the previous one were not performing well. Yeah, so also, like if the competition ends like this, guitar will still win. So it's always first come, first serve. If all of us submit the one he has submitted right now and get 0.4482, he'll still win the prize because he did it like fast. Yeah? If there is a tie, the person who did it first will win. But yeah. So go crazy, man. Go crazy, guys. Go crazy. So that means Gitau, you have been coding with me while streaming. I mean that's so motivating, man. That's so motivating. You've been coding with me. That's so motivating. That's so motivating. Also, if you have not followed me on Twitch, please follow me on Twitch. Please follow me on Twitch. Subscribe to my YouTube channel. I mean, guitar. That's so motivating. Thanks, man. Thanks, man. You're the reason I like. You're the kind of people that make me like want to do this even more. Thank you, man. Thank you. That's so motivating, man. That's so motivating. Thanks for you've been cutting. That's so motivating, man. That's so motivating, bro. You have no idea. Cool. So our new one has finished. Um, yeah. Yeah. So like the order matters. The order matters. I don't want to try the one Guitar did, and I'm sure he's doing this right now. So let's try just a random one. This is the last one, then we end the stream. So if you want to get a good score like Guitar, run the model he has run as well. Yeah. And then from next week, we start now training, like now running the training, creating the training notebooks, running the training. Yeah. And now we have an advantage. You want to like run from scratch. You see, for example, guitar, the model you have just like got the better score. So all you have to do is go to my GitHub repo, check the notebook that trains the CTC models, and then start from that baseline. Do not start from the base. You see, like for example, let me just change this and then run it, and then we talk about how to improve that 0.44 score. Yeah, so you come to my GitHub repo here. You see, like for example, let's see. Yeah, you see, I started from someone's baseline. So for example, you'll come, take this, wait. You'll come, take, I see, this one is the one that gave you the better score. You come, copy this, replace it here. You see here, replace it here. Then you're good to go. You just start from this baseline, meaning you want to get a better score. I mean, a worse score than 0.44. Yeah, so you'll get better scores than 0.44. But also the data matters. The data matters, yeah? Yeah, and I showed you guys in the first stream how to get the data. Yeah, so like you have an edge now. You have an edge now. So also the first come first serve. So urgency matters. Urgency matters. Yeah, this is the last one. Then I end the stream. This is the last one. Then I end the stream. But the video will be uploaded on YouTube before midnight. Yeah, so be on the lookout for that. Be on the lookout for that.
Well, I woke up this morning. I made some coffee.
So everyone else, do not miss. Never miss the live stream. Urgency matters, man. Urgency matters. Urgency matters. Do not miss the live stream. The live streams are always Tuesday, Wednesday, Thursday. Tuesday, Wednesday, Thursdays at 8:30 to 10. Tuesdays, Wednesdays, Thursdays at 8:30 to 10. Yeah. Never miss the live streams. But you'll always find the replays on YouTube. Always, always, always. Yeah, so we run this, then we go to sleep now. The others you can test like the others. You can test it. There are many. And you can find even others. For example, the Badili one. You can even test this one. Jonas. Yeah, you can even test this one. This was the base I used to fine tune my models on. Wait. Who is this? That username is actually so hard. Sama. Thank you for joining the stream, by the way. Yeah, so this is the last one, then I call it at night. Yeah. Nice, we got even a better score. Sorry, guitar. But it's not that good, honestly. It's just like, whoa, guitar. Nice, man. Nice. Thank you for joining my stream. You can now see the benefits of joining my stream, so thank you so much, man. Yeah, thank you so much, guys. Thank you so much, guys. Have an amazing night. Adios. You'll catch the replay on YouTube. Yeah, and for everyone who has chatted on the stream chat, thank you for making this live interactive. Bye guys.